Your online application's starting to fail. It's crawling on the network just as fast as a snail. We need evented programming starting from the top. Better write some code so the world doesn't stop. With the non-blocking model, we will be just fine. Built on Google Chrome's V8 runtime. And all you need to do is write some JavaScript code and use the real-time web with Node.
Hello, I'm Greg Pollock, and you're watching Real-Time Web with Node.js. In this level, we're going to give you a quick introduction to Node, talk about what it is, what it isn't, blocking, non-blocking, what evented programming is, and then finally what that event loop is that you've heard about with Node. So let's jump into it. Node.js allows you to build scalable network applications using JavaScript on server side. Underneath the covers of Node, you're going to find the V8 JavaScript runtime. This is the same runtime that is used in your Chrome browser on your client side. What Node does is provides a wrapper around this engine, providing additional functionality for building network applications. It's really fast. Why is it fast? Well, if you looked under the covers of Node and this runtime, you'd find it's all written in C, which obviously is very fast. So what can you build with Node? Well, here's a couple examples. You could build a WebSocket server. So a good example of this is maybe a chat server where you have your browsers, lots of browsers connecting to the server, and there's chat going on, and you're sending messages back and forth between the client and the server, and the socket stays open. You could also do a file upload client. So when you think about uploading big, large files, you want to be able to do it in a way that's not blocking. So you can do more than one file at a time and maybe even start processing the file as you get the first few pieces of it. Also, you could create an ad server. When you think about ads that get served on web pages all over the net, they need to be really fast. These are, maybe images that are appearing on other people's websites, and they need to be able to be rapid and quick across the network. Also, any real-time data apps. So not just from on the internet, not just from your browser to your server, but any sort of network servers, maybe even local network servers, would be a good fit for Node.js. Node.js is not a web framework. It's not going to replace Rails. It's not going to replace Django. It's very low-level network communication we're talking about here. There are libraries that people have written that sit on top of Node to be a web framework, but Node at its most basic level is not that. Node is also not for beginners because we are talking about network communication. Node is also not a multi-threaded application. When we write our applications with Node, we write them as if we're dealing with a single-threaded server. Before we get into some actual Node code, we need to make sure everybody knows the difference between blocking code and non-blocking code. So here's some pseudocode to print some file contents. First, we want to read the file from the file system, set it equal to the contents variable, print the contents variable, and then do something else. So if we think about how this code executes, first, we read from the file system. We can't actually print out the contents until we've read out all of the contents from the file, so it's kind of blocking here. And then, obviously, we can do something else. What would a non-blocking version of this code look like? Well, we might read the file from the file system. Whenever we're complete with that, print out the contents from the file, and then finally do something else. That technique there, saying when you're complete, do this, we call a callback. We're going to call back that function once the file is done reading. Executing the pseudocode might go like this, where we read the file from the file system. We might do something else, so it's simply going to continue on, and then at any point in time in the future, when it's done reading the file, it's going to print the contents. Now here's some actual Node code. First of all, the blocking version of reading out the file might look like this, where we're getting all the contents of the file, we're then logging that out, and then doing something else. So obviously when this gets executed, it just runs one at a time. The non-blocking version of this in Node is going to call readFile, and look at this. We're actually sending in a function as the second parameter to readFile. That's our callback. And when we get the contents, log the contents, and then we can say doing something else. So when we execute this, as we mentioned, it's going to start reading the file, It's then going to continue execution, and when it's done reading the file, it's going to print out the contents at some point in the future. Hopefully this JavaScript syntax looks familiar, and there's another way we could write this which would be just fine. We could declare the function and set that equal to a variable, and then when we call readFile, we could send that function into readFile. Either syntax would work just fine. They do the same thing. Let's take a closer look at this code, and let's see what happens when we're reading two files at the same time. First of all, if we had to do this in a blocking way, and we look at the timeline, if this was blocking, it would read one file and then the next file. However, since our code is non-blocking, if we read two files at the same time, they're going to read in parallel and happen much quicker. Now it's time for our Node.js hello world, or in our case, let's do a hello dog. So our first line in this file, we need to require the HTTP module. So we're including another library. This is how we include libraries typically in Node. We're going to call the createServer function. That function takes as its single parameter a callback with request and response. We're then going to write a 200 status code in the header for the response. We're going to write out the response body. And then finally, we're going to end the response connection. We want our server to listen on port 8080. And then to ensure our server is running, we're simply going to log out listening on port 8080. If we run the server on our command line, we're going to see that it prints out listening on port 8080. And then if we use the curl command line tool to hit the server, it's going to return to us, hello, this is dog. We could also just call up our browser and go to that port, and we would get the same result. Now let's talk a little bit about how Node executes this code. The first time we go through this code and execute it, Node is going to register events. In this case, we're registering the request event for whenever a request comes in. Once it gets done executing the script, Node goes into something called an event loop. Right? It's checking for events continuously. Did a request come in? Did a request come in? Did a request come in? As soon as a request comes in, it's going to trigger that event, and it's going to run the callback that we wrote and print our hello, this is dog. Now you might be wondering, why are we writing JavaScript? Well, the creator of Node, Ryan Dahl, wrote this really good quote which kind of explains why. I'll let you read it. So JavaScript makes it really easy for us to program in an evented way, to do evented programming using that event loop and write code that is potentially non-blocking. When we run a Node application, like we said, it registers a bunch of events like request, connection, or close. And those events sometimes even trigger even more events. And then we have this event loop, which is constantly looking for events. And once our application gets into that event loop, it can start triggering and emitting events into what we might call our event queue. So if a request event comes in at the same time as a close event, well, events are going to be processed one at a time on our event loop. Let's make our hello world code a little bit more complex and simulate a long-running process. So here we're creating our server. We write the status code back to the response. We write dog is running. Now we're going to do a timeout. We're going to pause for about 5 seconds to simulate a long-running process. Once that timeout is done, we're going to write out dog is done to the response and end the response. We're going to pause for 500 milliseconds, which is basically 5 seconds, and listen on port 8080. You might notice here there are two different events in our code. We have the request event, which we should be familiar with from earlier, and we also have a timeout event. So every time a request comes in, it's going to create a new event, a timeout event, which will then be called back in 5 seconds. We're going to send in 2 requests to our Hello World server with the timeout and see what happens. So our first request comes in, triggers that request event, the request callback executes, that set timeout code registers, and it's going to wait 5 seconds. Meanwhile, another request comes in, triggers that request event again, the callback executes, the set timeout registers, and now this has to wait 5 seconds. Then when our first timeout is done, it's going to trigger that set timeout event, which will trigger the set timeout callback, and it returns that response. Then our second request is going to trigger the event and do the callback, and so on and so forth. So as you can see, 2 requests can happen at the same time, and nothing is blocking. what would this look like, though, if that set timeout was blocking? Well, let's try it. So a request comes in, the request callback executes, and the set timeout locks the world, right? It stops the world, and nothing else can execute on this process while we are on a timeout. It is officially blocked. So if a request tries to come in, well, it just has to wait for the server to get unlocked. Once it is unblocked, it'll trigger the set timeout event, and so on and so forth, and the second request gets to lock the server again. Now, obviously, blocking is bad, and you might be wondering, why would anybody write a programming language or a framework that blocks and stops the world? Well, you find this in a lot of programming languages. Often when you do a call out to web services, it'll block. When you're doing a read or write to the database, it'll block. Or when you're calling out to a C extension, it will block. And this is one of the reasons why people love Node.js. Because from the very start with Node, its purpose was to be completely non-blocking, and all of the libraries that you'll find for Node are all non-blocking. That's pretty cool. Well, we've reached the end of Level 1. It's time to get your hands dirty in the challenges, so we'll see you at Level 2.